I'd like to start out by introducing myself and thanking you for attending. My name is Lance Zurich, and of course, I'd like to thank you for taking the time to attend today. I am the product manager for the Fischertechnik division over here at Studica, and today, of course, we're going to provide you with an overview of Fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in things like CTE training, if you're possibly a college professor or an industrial trainer teaching programming skills required in manufacturing, if you're involved with a company looking for ways to demonstrate their software-based solutions, or maybe you're just someone looking for ways to make IoT-related concepts easier to understand to employees or customers, in any case, I believe this presentation is going to offer some important options for you to consider. We're going to start off by considering the skills gap. Now, if you've attended any of our other Fischertechnik education-focused webinars, you've probably heard me discuss the importance of STEM education. STEM, of course, is an acronym, and it stands for Science, Technology, Engineering, and Mathematics. And at this point, it should really go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. As most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions that we're going to be looking at in this presentation, let's just stop and consider that last skill area I just touched upon, that of being a PLC programmer. First off, for anyone who may not be familiar, let me just explain real briefly what a PLC is. The term PLC is also an acronym, the letters of which stand for Programmable Logic Controller. And essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes that are typically found in an industrial setting, such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of systems such as this grows exponentially. And to get a clear idea of just how highly prized these programming skills are, we're going to talk about some salary figures for PLC programmers as quoted from job search website nuvu.com. To quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at the list of job openings that were current at that time for PLC programmers on the nuvu.com website, and this would have been in February of 2020. Now, the listings at that time showed 15 positions being advertised with salaries of over $75,000, and 2 of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. Now, at the same time as this workforce of tomorrow gets their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering programs like this. So how long does it take to learn PLC skills? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. Of course, to become truly proficient in all 5 of the most widely used PLC programming languages listed here, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available, things like high school CTE programs, adult continuing education programs, vocational training, technical training in trade schools, and employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, and that's whether in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and the roteness of video presentations and instead just make it all more realistic and hands-on? But before we go there, there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. In each of these cases and more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of Fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled, small-scale models which are designed to replicate, in both appearance and function, various automated robotic machines and systems that you'll commonly find in commercial manufacturing. But before we begin to look at each of these models, I'm going to provide you with just a little bit of background on exactly what Fischertechnik is. Fischertechnik has been creating tools for teaching students of all ages about how technology works for over 50 years, all based around their unique building system. Now, what makes the Fischertechnik building system unique is that unlike other popular construction systems where the components are designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block, as you see here on this slide, is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts in the Fischertechnik system are designed to lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help to address very specific design needs. The Fischertechnik system was developed back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography. This was back in 1949, and he was also the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce many components used in the automobile assembly process, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fischertechnik sets, and it's whether those sets that are intended for the retail market or for classroom use, such as you see here, the focus has always been on helping to foster an understanding of technology. Now, many of the products offered by Fischertechnik for the education sector are what we call subject-specific sets, focusing on different STEM-related subject areas, things like mechatronics, pneumatics, robotics, or perhaps renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique Fischertechnik system, and then perform various experiments which allow them to explore and understand the various aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program, and in this case, the focus is on project-based learning. In these project-based learning programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and to create various devices and automated machines to meet the criteria being put forth in a series of real-world scenarios, all based upon their own trial and error experimentation and research. The line of Fischertechnik simulation solutions, which are the focus of today's presentation, are something much different. The line consists of not of kits but once again of a series of pre-assembled small-scale models, which are designed to replicate in appearance and function various automated robotic machines and systems. Models included in the Fischertechnik simulation line currently include things such as conveyor belts, punching machines, 3-axis pick-and-place robots, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations made up of a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, all designed to work together as one self-contained material cycle. But before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using Fischertechnik solutions. Now, I will apologize in advance as the first few points are things I've touched upon before, but in each case, I do think it's worth repeating. First, Fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, in both appearance and function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in-office demonstrations, but they're also ideal for demonstrating software or other technology-based offerings in a trade show environment. The next aspect is quality. Each Fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of these models is available in a 24-volt version designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, Siemens controllers, or if you use controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or many others. In any case, you can control these 24-volt versions of the models with the PLC that you prefer to use. Likewise, just as you can use your choice of controller, you can also use your choice of the preferred programming languages out of the choices you see here: ladder diagrams, sequential function charts, functional block diagrams, structured text, or instruction list. Please note, though, that with all of these 24-volt versions, no PLC is included, and all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes using PLC programming. In addition, for non-industrial users and educators who are not versed in or familiar with PLC programming, there are several models which are still available in 9-volt variations. These 9-volt versions ship pre-wired to Fischertechnik's own proprietary robotic controllers, which are known as the Robotics TXT controllers. And in each case, the controllers are pre-programmed using Fischertechnik's own RoboPro graphic programming software. The only additional component required with these 9-volt versions will be the addition of 1 or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these models should be ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, which is also, of course, known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, Fischertechnik now offers a special IoT-focused version of the factory simulation designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. In these instances, the model is designed to be both controlled and monitored from a special web-based dashboard. And we're, of course, going to discuss this in more detail a little bit later in the presentation. Finally, Fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you've probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of that price. And they're also, again, compact, realistic, and high-quality learning and demonstration tools. So with all that being said, let's now take a look at each of the models which are available. First up, we're going to look at the vacuum gripper robot. As you're going to see here, the vacuum gripper robot is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. This model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you'll see on the model in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt version of this model, which is currently the only version available, as well as all of the first 5 24-volt models we're going to be looking at today, each comes with a relay board for motor polarity reversal and both a multi-pin connector, which is 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as all 24-volt versions, will require you to provide the PLC and the programming. I will also mention that for this and all of the models we're going to look at today, the specs are also detailed in the product listings found on the Studico website and the Fischertechnik.biz website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Just going to let this run for a few more seconds. And there we go. Next up, we're going to look at the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on this model include 2 encoder motors, 2 MIDI motors, 4 push-button limit switches, 2 phototransistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. I will mention that this particular model is a favorite among educators that I've spoken with who teach programming. And the reason for that is because it gives you a lot to work with its students in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each of these workpieces, each step of which will, of course, require its own very specific coding. The dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. A limited edition 9-volt version is also available at this time, which again is pre-wired to a pre-programmed robotics TXT controller. And in that case, one 120-volt power adapter is required. The next model we're looking at is the multi-processing station with oven. This model that you're going to see features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 MIDI motors, 6 push-button limit switches, 2 phototransistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of this model is the 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal, and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. There is a limited edition 9-volt version that in this case is connected to 2 robotics TXT controllers, and so in this instance 2 120-volt power adapters would be required for all operations. And that was that. The next model we're looking at is the sorting line with color detection. And we'll get this back here. This simulation features a system for detecting work pieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal, and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you need to provide the PLC and the programming. The limited edition 9-volt version again comes pre-wired to a pre-programmed TXT controller, and 1 120-volt power adapter is required for use. We'll just watch as this finishes up the sorting of the pieces. And there we go. The next model we're looking at is the factory simulation, which combines the 4 models that we've just reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection. It combines them into one self-contained material cycle. The cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with oven. After the workpiece has been processed by this machine, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. As we've already discussed the components of each of these models previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this model and any of the factory simulation models we're going to be looking at today can only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in very high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. I can tell you right now they're moving fairly well, but as we get into the school ordering season, we can get a little bit behind on these. A few other things to note. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. In the instance of the 9-volt version, it is wired to 5 robotics TXT controllers, and because of this, it's going to require 3 120-volt power adapters. The reason for only 3 is because of the way the controllers are daisy-chained. Now, as always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required. Again, each station of the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations we've just discussed, or also some other models that we're going to be discussing at the end of the presentation. And in this case, if you wanted to transport the model or you just wanted to protect it, this is a good option to keep in mind. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model. And it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. Now, I do have some dimensions here to share, but I will tell you that they are changing right now because the case is actually being sized up a little bit to incorporate a PLC and the additional wiring that you would usually play into this. But the dimensions we had here were 41 by 33 by 17 inches with a weight of about 53 pounds. Again, on the new versions of this case that are going to be shipping very shortly, it's going to be a little bit longer, a little bit wider to, again, incorporate a PLC and the wiring that would be required. I do want to note, though, that even when using the travel case, the models would still need to be shipped flat. So on that note, let's move right along. And the next model we're going to look at is the conveyor belt. This is basically a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. Now, as before, the standard 24-volt variation, which you see here, includes a multi-pin connector. In this case, it's a 26-pin connector with a 2.54 millimeter grid. And for a limited time, we also offer 9-volt versions pre-wired to the robotics TXT controller, as shown here. And in this case, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except this time it has the machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in the standard 24-volt variation with a 26-pin connector and a 2.54 millimeter grid, as you see in this picture. And for a limited time, we will be offering a 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the index line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in the standard 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with PLC, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controllers and requiring one 120-volt power adapter for operation. Next is a variation on the idea of a pick-and-place robot. This is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions on the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And again, this comes in either a 9-volt version with a 26 pin connector and a 2.5 millimeter, 2.54 millimeter grid, designed for use with PLC and programming of your choice, or in a 9-volt version, which in this case is not a limited availability model. This is a standard model. And once again, it comes pre-wired to a pre-programmed robotics TXT controller, and it does require one 120 volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next pair of simulation models focuses on the area of IoT and is designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and they are available in both 24-volt versions for use with PLC and also 9-volt variations for classroom and demonstration purposes. They have been designed to help address how the recent changes in industrial production, which were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of just how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. The following topics can be addressed with the Fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models we've previously discussed today. Besides that, most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enables the positions of each workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, as there are two variations of this model, let's go over very briefly what makes them different aside from the voltage requirements. We'll begin by focusing on the 24-volt version and what makes it unique. First, it is a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one Fischertechnik's robotic TXT controller. The TXT controller in this case serves as the MQTT broker and interface to the Fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the Fischertechnik cloud, but it also allows you to calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the pre-assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. They also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features, unlike any of the previous 24-volt models that we've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a special sample program. Now, this program was designed in structured text format and was created based upon a Siemens S7 1500 PLC, and this is available for download on GitHub when you purchase the model. Of course, the new Training Factory can also be controlled with other PLC models and other brands once the end user makes some small adjustments to the sample program. The source codes needed are also available for download from GitHub. Now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the Fischertechnik website or from our website. If you can't find it, you can also email us, which I'll give you information on, and we can provide it that way as well. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions that we've looked at previously today, these TXT controllers are programmed not using RoboPro software, but instead using C, C++. Again, all of the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF that accompanies this version, you should be able to get started pretty quickly. Now, the 9-volt version will require the addition of 3 120-volt power adapters for powering, of course, the TXT controllers. It will require the ability to access the internet, as well as a tablet or device for accessing a cloud-based dashboard. And it goes without saying, you also require these things for using the 24-volt version. You, of course, need to have access to the internet, and you will need some sort of a tablet or device for accessing the cloud-based dashboard. Dimensions for these factory models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds each. Now, as with the two factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that essentially is the Training Factory Industry 4.0 model, now available in both 9-volt and 24-volt variations. Of course, you might well be wondering, how much do these models cost? So with that in mind, let's take a quick review of each option we've just discussed, along with the pricing for each. The vacuum gripper robot, currently available in a 24-volt version only, and they are $1,010 per unit. The automated high bay warehouse is available in both the 24-volt version at $1,159 or in a 9-volt version with the TXT controller for $1,319. The multi-processing station with oven in the 24-volt version is $1,010. In the 9-volt version is $1,479. The sorting line with color detection is $840 per unit in the 24-volt version, or $1,129 in the 9-volt version. The factory simulation 24-volt version is $4,369 per unit. The 9-volt version is $5,239 per unit. These all being list prices, of course. The conveyor belt 24-volt version is $252 each. The 9-volt version is $519 each, once again wired to the TXT controller. The punching machine with conveyor belt in the 24-volt version is $336. In the 9-volt version, it's $599 per unit. The 3D robot in the 24-volt version is $909, and in the 9-volt version is $1,219. The indexed line with 2 machining stations in the 24-volt version is $909 per unit. In the 9-volt version, they are $1,399 per unit. And the Training Factory Industry 4.0 in the 24-volt version, you're looking at $8,235 per unit. In the 9-volt version, you are looking at the same $8,235 per unit. There are also 2 new variations that are actually, that I just put this slide up for. Actually, we did just start getting them in, so they are available. There is a version of the Training Factory Industry 4.0. These are 24-volt versions. There is one that has the PLC connections all set up for you. So all the wiring and everything up to the PLC itself are included with that version. That is $11,088, I should say. There is also a version that includes everything. The Siemens PLC S7 1500, the wiring and the power supplies, the 24-volt power supplies are included. In the educational version of this model, it is $16,715. If you're purchasing it for commercial use, it is $18,900 per unit. And I should mention that both of these versions, the one with just the PLC wiring and the one with the PLC itself, in either case, the 24-volt power supplies do come with these. And these are just becoming available right now, literally right now. Other items that I've mentioned, the 120-volt power adapters that I keep mentioning for use with the 9-volt models. Also, you would get one each of these with the Training Factory Industry 4.0 24-volt versions, because they do have that one TXT controller that does need to be powered. In any of these cases, you're looking at $12.99 per power adapter. And the travel and storage case for all of the factory simulation and Training Factory Industry 4.0 models that we've looked at today, including the 2 that I just mentioned. This is the newly expanded version, a little bit wider than what I had given specs for before. It is $1,399 per unit. So on that note, if you have any questions, this would be the time to use the chat windows, the question and answer windows, all found on the Zoom toolbar. You can just type in any questions you might have, and I will do my best to answer them. I will give it a 1. I will give it a 2. If I don't see anything come up, I'm just going to start giving you some information. So if you want to write down any of these things, you can. So if you'd like to take the next step, if you would like to request a full color brochure with the current pricing, if you'd like to ask any questions of us directly, if you'd like to request a quote, or if you'd like to speak with your dedicated educational representative over here in Studica, you can do any of these things by giving us a call. Our number toll free is 888-561-7521. If you would like to email us about anything that we've talked about today, any aspect of Fischertechnik, if you want to know more about any of these things, just general information, you can email us at info, that's INFO at studica.com, that's STUDICA.com. If you have any questions of me specifically, anything that I talked about today, anything that you wish I would have talked about today, any questions you might have specifically about any of the training models we've gone over today, or any of the Fischertechnik solutions for education, you can also email me directly. This is my direct email. It is lance.zurich. That is LANCE.ZUREK @studica.com. So on that note, as I see no questions coming up, I am going to thank you very much for attending today's presentation. Have a great day. We look forward to hearing from you soon. Take care.